All right, we're going to look at a quick introduction to sedimentary rocks as part of the rock and roll project. We're going to look at things like the formation of sedimentary rocks, how we can figure out the age, and how we might identify sedimentary rocks. So starting with formation, we've got these processes that we'll always talk about. These 5 steps that are the processes of making a sedimentary rock. So again, sedimentary rocks are made up of small pieces of other rocks, and so they may have small pieces of other sedimentary rocks, small pieces of other igneous rocks, small pieces of other metamorphic rocks, and those things have to somehow get in the same place and come together to make a sedimentary rock. So we're going to talk about each of these processes: weathering, erosion, deposition, compaction, and lithification. I'm going to give you some basic definitions of these. So first off, weathering, that is the process where we take other rocks and we break them into smaller pieces. So this is the process where we make pieces which we will call sediments or clasts. And we will talk about later some organizations that we have on those clasts. Let me fix that for you real quick, just so it's a little more clear. And that's CLASTS. So we're talking about these pieces of rocks, and that's called weathering. And there's lots of processes that can cause weathering. It can be water running, it can be rain, it can be mudslides, it can be wind. All of these things play a role in this weathering. It can be that freezing and thawing of water can break rocks apart. Roots can break rocks apart. All of these processes are part of this weathering. Okay, and our next step, erosion. Oftentimes we get a confusion between erosion and weathering. Sometimes we commonly think of erosion as the breaking down of things, but that's just weathering. Erosion is actually the transportation. So the movement of those pieces once they're broken apart somewhere else. Okay, so the erosion is we take those small pieces and we're moving them somewhere else. Again, some common ways that we have erosion is wind, gravity, if things are falling off of mountains or down hills or even just down small slopes. If we're talking about water is another common way. Snow and ice, if we're talking about glaciers and things like that. All of those are examples of ways we can have erosion, ways that pieces of rock can be moved. Okay. The next one is deposition. And the easiest way to remember what this is we think of the word deposit. And if you're going to deposit money into your bank account, you take it from one place and you put it, and it rests and stays there. So deposition, again, we're going to think of this word of deposit. That's where we stop moving something, so we allow it to settle. So some examples, and I've got a few pictures on here that we can look at and see some examples. If we look here, this is an example of pieces of rock that have been moved by this river or down this hillside, and then they've been deposited. So this is an example of deposition happening. Okay, so they've been deposited right there. Okay, so that's an example of deposition. Just while we're looking at these, this is an example of erosion. We've got this muddy river, and it's moving pieces of the soil, pieces of the ground along. Weathering, here's an example. This is a weathered rock. Pieces have come off of that. Okay, so next we have this compaction. Okay, compaction is the process by once we've deposited a rock that we're then going to start pushing pieces of that rock together, okay, with other rocks. Okay, so we're going to have compaction. Typically how this happens on Earth is when we put other layers of sediments on top. So we start stacking layers of sediments on top of each other. That's usually when we get this process of we stack sediments, that's when we get this process of compaction. As more and more layers get put on top of that, those lower layers get compacted closer and closer together. We're reducing the space between all of these pieces of rocks. Okay, and our last one is this, what we will call lithification. Lithification is the process of where we're basically gluing or cementing the pieces together. Okay, so we're talking about, we're gluing or cementing them, and we're not actually, using glue. There's not glue factories underneath the earth. What we're talking about is typically we have, chemicals or things that are inside of them, and as water evaporates or as they get heated, because they're getting slightly deeper under the earth, those will leave and they'll solidify and hold those rocks together. And there's several examples that you can look at of how lithification happens, but our main thing that we're focusing on is it's the process where we take all of those pieces that have been squished together and then we get them to stay, and we call that lithification. Okay, we are going to now look at the next slide, which is going to start talking about the sizes of our sediments. And we're going to have several examples here of sediments and their different sizes. So we will be looking at, and I'll list them on this size, with the largest on the top, and we'll have the smallest on the bottom. And we want to know these. We need to know these names because they describe all these different clasts or sizes of pieces of rocks. That's how we classify them. So we're going to have our largest up here, and we're going to continue down till we have our smallest. And I'm going to list these names from largest to smallest on here for you. Okay, first thing is our two major classifications that we're looking at. We're going to look at gravel and another size that we'll get to later. And this is kind of a large classification. So I'm going to start with calling this gravel. This is kind of a hierarchical classification. And the first and the largest part inside of gravel is boulders. And boulders are anything larger than 10 inches. So we're talking, anything larger than this is going to be a boulder. So, we could have boulders that are as big as a car, big as a house, and down to, about 10 inches. And those are going to be what we call boulders. And each of these slides will have a picture of this particular size, and just to give you an idea of what we're looking at. Okay, our next size, still in gravel, is a cobble. So you've heard of, cobble roads or cobblestone. That's exactly what we're talking about. These rocks that are anywhere from 2.5, about the size of a baseball or tennis ball, up to, again, that 10 inches is what we will call cobble. And again, sedimentary rocks can be made of, you could have a sedimentary rock made of a bunch of boulders. It would be a very, very, we're talking about sedimentary rock on like a mountainside, not one that you'd find and be able to pick up. But it's still considered a sedimentary rock. All right, our next one that we're looking at is a pebble. And our pebbles are going to be from that 0.16 inches, so less than an inch, all the way up to that 2.5 inches. So we're talking about the size of a bead out to about the size of, again, a tennis ball or golf ball size. All right, so next in our size is going to be what we call granules, and those are almost our last size as far as gravel is concerned. But a granule is, if you've seen like sea salt or large grains of sand. Our next size is going to be sand, and we're smaller than that. We're talking about 0.4 to 0.16 of an inch. So small chunks of rock here. And then the next one that we're looking at is sand. And sand is still part of this gravel, and I think we all have a great idea of what sand is and about the sizes that we're talking about. So then our next section that we're going to look at is what we're going to have majorly classified as mud. And we will look at two sizes. There are more sizes, smaller classifications than this that we could use, but we're going to just focus mostly on these two. The first one is silt. And again, we're getting very small at this point. You can see we're talking from 0.0025 inches all the way down to 0.0015. And that's difficult even for us to start to describe things that are similar to that. But these ones, when we're looking at silt and clay, which is our next option, kind of the best thing that we can think about when we're thinking about silt and clay is flour. That's been what I've found is the best one that people can understand. If we're talking about chunks or pieces of flour, very, very fine, very, very small, that's what we mean by silt and clay. And that's often how silt and clay can feel. Is they're very, very small. You can hardly tell that there are pieces there. So that's what we're talking about. And those are the sizes of the clasts, and that's a word that we want to remember. This word here, clasts. That is our pieces of our sedimentary rocks. And oftentimes we'll find rocks that are named similar to these things. So we might have sandstone or siltstone, and that's a description of how big the pieces are inside of those rocks. Okay, just a couple more slides here. We're looking at dating or determining the age of a sedimentary rock. We can't directly date and figure out how old a sedimentary rock is, so we have to use, again, sandwich radiometric data or bracketing radiometric data. And again, what we mean by that, if, for example, we knew the age of this rock because it was igneous and we were able to exactly determine the age of that rock through radiometric dating, and we also knew, say, the age of this rock or this layer of rock because it was igneous, and it probably wouldn't have a skull inside of it. But if we knew, say, that hypothetically that we knew the age of these two layers of rock, and we were trying to determine the age of, say, this layer of sedimentary rock here, we are able to use the data above and below to help us to sandwich or to give ourselves a bracket of how old that is. So if we knew, like we see here, this layer happened to be let's say 100,000 years ago, and that this one was, say, 750,000 years ago, just hypothetically picking those years, we would know that this layer was somewhere between these. If we found some fossil or we found some artifact in there, we would be able to say, this is somewhere between these two ages. And again, it's not as precise. We can't say, we know it's this old, but we can say it's somewhere in between here. All right, so we're going to move on. We're going to look at some identification of some particular types of sedimentary rocks, and we're going to start with we're going to look at grain sizes, and we're going to look at rock names. We're also going to look at textures. And what this means here by clastic means that there are actual clasts or pieces of rocks that we can see. And this one is known as a conglomerate, and that means it's made up of all of these different pieces of rocks that are often different sizes. This is probably one of the easier sedimentary rocks to identify because you can actually see different chunks of rocks of different sizes all stuck together inside here. We've got this conglomerate. We've got all these pieces of these rocks together. So this is an example of what a conglomerate looks like. You see any rock like that, it's going to have to be a sedimentary rock. The next one we're going to look at is sandstone, and this is what I was speaking on before, that oftentimes rocks or stones are named after the the size of the clasts inside of them. So we know this one is primarily made up of sand, and we can see the distinctions between the different colors of the sand on this image. And so it's made up of sand that's been put together, it's been compacted, it's been lithified, and has become this rock. Next one we're going to look at is siltstone, and again, if you remember, siltstone or mudstone is smaller. The actual clast size is smaller, and here, we can't see those different clasts as well as we could with the sandstone, and especially not as well as we could with the conglomerate. But if we were able to look really carefully, and we might rub it with our fingers, we might be able to feel some of those small pieces, and that's siltstone. It's made up of silt or made up of mud, and that's been, again, it's been eroded, excuse me, it's been weathered, it's been eroded, it's been deposited somewhere, it's had deposition, it's had been compacted, and it's been lithified into this stone. Okay, let's look at another type of sedimentary rock where we're talking about chemical. And these happen not necessarily in the same processes that we have through the other steps that we've had. We've got these chemical processes, and that usually involves some type of reaction where water leaves or something happens to really solidify these rocks together. And they're generally solidified by crystals, very, very microscopic crystals growing and holding these pieces together. We've got limestone that's holding those together, and as our second example, we've got rock salt. Now these are both chemical sedimentary rocks that are formed in similar processes as other sedimentary rocks, where we've got things joined together, and we've got this structure that's holding them together, which happens in our lithification, and that's why they're characterized with sedimentary rocks. Our third main type of sedimentary rocks is biological, meaning that it's made up of stuff that was once alive. And one that's probably the most common, or one that you've certainly heard of, is coal, which is made up of biological material that has been buried for extended periods of time and has become this black rock that is called coal. We do and will talk about two types of coal. This is one of them. The other one is a metamorphic rock, is where we take this type of coal and it undergoes some heat and some pressure and is transformed into another type. Chalk is yet another type of of biological sedimentary rock, where it's made up of, often in this time, very small organisms, or the shells of organisms, and that's an example of that one. Here again, very similar to the one we just talked about, we can obviously see with this that there are biological things. We can see the shells of other animals that were there, and so this one is typically formed in the oceans or at the bottom of oceans, or where those are able to pile up and eventually be solidified together. So those are a few examples of some common sedimentary rocks that you'll run into, and an overview of the formation and some other characteristics of sedimentary rocks.